Chapter 9.2, Arithmetic Sequences and Partial Sums. So we're going to recognize, write, and find the nth term of arithmetic sequences, find nth partial sums of arithmetic sequences, and use arithmetic sequences to model and solve real-life problems. So a sequence whose consecutive terms have a common difference, that is called an arithmetic sequence. So a sequence is arithmetic when the difference between consecutive terms are the same. So for example, this sequence A1, A2, A3, A4, and so on is arithmetic when there is a number D such that A2 minus A1 equals A3 minus A2 equals A4 minus A3, and so on. That is the common difference D. The nth term of an arithmetic sequence, so to find the nth term of an arithmetic sequence, it has this form. A sub n equals A sub 1, so the first term, plus n minus 1, whatever term it is, times the common difference. So we're going to find the nth term, find a formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. So let's label what we know. So we know D is 3, A1 is 2. So we just use the formula. A sub n equals 2 plus n minus 1 times 3. So this is 2 plus 3n minus 3, or A sub n equals 3n minus 1. So try this next example, letter B. So if you tried it out, you should have gotten A sub n equals 5n minus 6. Example 3, we're going to write the terms of an arithmetic sequence. So we know the fourth term of an arithmetic sequence is 20, and the 13th term is 65. We're going to write the first 11 terms of this sequence. So first off, we know the fourth term is 20, and we know the 13th term is 65. And so what we want to do is A sub 13 equals A sub 4 plus our n is going to be 13 minus 4, which is 9. So this is going to be 9 times D. Okay? Then we plug in what we know. So the 13th term is 65 equals 20 plus 9D. So hopefully you see that this is from 4 to 13, that is 9 away, and so that's why that is 9. So then we solve for D, 9D, not 96, 9D. So minus 20, we get 45 equals 9D, or D equals 5. So next one we need to find is A1. So a couple ways to find A1. So here's one way to find A1. As you say, A sub 4 equals A sub 1 plus the fourth term, 4 minus 1 times the common difference of 5. So A sub 4 is 20. 20 equals A1 plus 4 minus 1 is 3 times 5. So this is 20, and then minus 15 equals A sub 1, or the first term is 5. Now we're supposed to write the first 11 terms. So if the first term is 5, then it's just going to go by 5. So first term is 5, common difference is 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and 55. And you could always check, too, that it is right, because the fourth term is 20, 1, 2, 3, 4. That is true. And if it kept on going, we would see that the 13th term would be 65. So try this example here. The 8th term of an arithmetic sequence is 25, and the 12th term is 41. Write the first 11 terms of this sequence. So if you tried it out, so you have A sub 8 equals 25, A sub 12 is 21, so 12 minus 8 is 4, and so you plug it all in, you get the common difference is 4, and then A sub 1, the first term is negative 3, and then you would should have gotten negative 3, 1, 5, 9, 13, 17, 21, 25, 29, 33, and 37. When you know the nth term of an arithmetic sequence and you know the common difference of the sequence, you can find the n plus 1th term by using the recursion formula. And so here is the recursion formula. With this formula, you can find any term of an arithmetic sequence, provided that you know the preceding term. So for example, when you know the first term, you can find the second term, and so forth. So let's use the recursion formula. Find the ninth term of the arithmetic sequence whose first two terms are 2 and 9. So a sub 1 is 2, a sub 2 is 9, and so we want to find a sub 9. So let's find the common difference. The difference is a2 minus a1, so that is going to be 9 minus 2, so the difference is 7. So let's plug in what we have. A sub n equals 2 plus n minus 1 times the common difference of 7. So a sub n equals 2 plus 7n minus 7, or a sub n equals 7n minus 5. And then what we're going to do is we need to find the ninth term, so we plug it in. A sub 9 equals 7 times 9 minus 5. So 63 minus 5, the answer is 58. So find the 10th term of the arithmetic sequence that begins with 7 and 15. So trying this out, you should have gotten the 10th term is 79. The formula or the rule would be a sub n equals 8 times n minus 1.